Good morning, class. This is the Unit 3 study guide. Today you will go through the study guide and you will take notes and write down the problems and learn how to solve these problems to prepare for tomorrow's test. So today we will be working on the review. You will have a rubric. Please put your name on it and your class period. The last few days we did solving by eliminations. We got through problems 1, 2, and 3, so please put 2 points for each. And you can see that what is the solution, number 1, of the system of equations. We graphed it first to solve. There's 3 methods for solving systems of equations. The 3 methods we've learned are graphing, elimination, and substitution. These lines are in slope-intercept form. So the slope is the coefficient in front of the variable. In this case, on line 1, the slope is 1. The y-intercept is -3. So you would start your graph at 0, -3. There's a second line. Line 2 has a slope of -1/2 and begins with the y-intercept -6. So here we have already graphed Thursday and Friday. We graphed and we started at -3 on the graph. 0, the point 0, -3 was located here, and we rise 1, run 1, rise 1, run 1, rise 1, run 1, and we had a nice purple line. On the other equation, we started at 0, -6, and we rose 1, run 2, rise 1, run 2, rise 1, run 2. Also from that 0, -6, we could go down 1, right 2, down 1, right 2. And our solution is where the 2 lines intersect. We could have also solved this equation by elimination. We have to get a variable that will eliminate, and since the coefficient here is 1 and this is -1/2, we have to manipulate the equations. How do we do that? We do not change the top equation. That's why we multiply times 1. But the bottom equation we multiply times 2. That allows us to get from y to 2y. And we go from -1/2x to -1x, and from -6 to -12. We're multiplying everything by 2. Now when we add these equations together, we get y plus 2y is a total of 3y. The equal sign. -3 minus 12 is -15. And by dividing by 3, we end up with y equals -5. That's only 1/2 of our solutions. We know from the previous page, on the graph, our answer was supposed to be -5 for the y-coordinate, but the x-coordinate is supposed to be -2. So if I go back here, I can pick either equation, line 1 or line 2, to solve. I'm going to use line 1, and I'm going to put in -5 in place of the y-coordinate. So I have -5 equals x minus 3. Add 3 to both sides. And we end up with -5 plus 3 is x equals negative 2. Problem number 2. We have this problem. This is the second problem. Y equals 1x minus 2. So we have a slope here of 1 over 1. And we have a y-intercept of negative 2. So we have to start at 0, negative 2. And we rise 1, run 1. Rise 1, run 1. Rise 1, run 1. The second equation we'll do in purple. And it's got a slope of 5. So that's 5 over 1. So that means we're going to go up 5 and right 1. And we're going to start at 0, 2. So start at 0, 2. And we rise 5. It's positive. So it's up 5. 1, 2, 3, 4, 5. Run 1. Put a dot. And we can also go down 1, 2, 3, 4, 5, and left 1. 1, 2, 3, 4. I went a little bit off the thing, so if I draw this line, I should intersect. And it looks like I intersect at negative 1, comma, negative 3. There's an easy way to check if that's right. If I put negative 1 in here, I'm going to get negative 3 equals negative 1 minus 2. That's true. And if I put y in here, negative 3 equals 5 times negative 1 plus 2. That is also true, because 5 times negative 1 is negative 5 plus 2 is negative 3, which equals negative 3. Problem 2 can be solved by also a substitution, an alternative method. We're going to substitute the x minus 2 in for this y right here. And we're going to get x minus 2 equals 5x plus 2. And to make things quick, I want to get all the x's on one side. So I'll subtract x on this side. And I will, since I don't want 0 on the left, I'm going to subtract 2. Make it real fast. Build the wall. X minus x is 0. 2 minus 2 is 0. And I get negative 4 equals 4x. So x equals negative 1, which we had in the graph. So if x is negative 1, then y equals x minus 2. And we know x is negative 1, so we put negative 1 minus 2. Y equals negative 3. It's very elegant. Negative 1, comma, negative 3 is your final answer. It matches the answer from the previous page that you can see right there. Problem 3. Find the exact solution to the system of equations below. Show your work and explain your steps. Again, let's try elimination. We can do elimination pretty quick if we multiply the bottom equation times 2, the top equation times 1. I get 2x minus y equals 1. 2x plus y equals 2. That allows me to, when I add these together, I can eliminate the y's, and I have 4x equals 3. If I divide by 4, I get x equals 3/4. Okay, the math gets a little bit tricky here on the next. These are, I think this equation, since it's all positive, might be a little easier. So let's use equation 2. X plus 1/2 y equals 1. What do we know? Y, we know x. X is 3/4. So let's put 3/4 in for x. Plus 1/2 y equals 1. I'm going to subtract 3/4. And I eliminate. I have 1/2 y equals 1/4. Okay, well I need to get to 1y, so I need to multiply by 2, because 2 times 1/2 is 1y, and I get 2/4, which can be simplified. 2/4 is the same as 1/2. They both share a 2 as a common term. And I write my final answer as an ordered pair, 3/4, 1/2. At what point in the coordinate plane do the lines defined by x plus y equals -1 and x minus y equal 2 intersect? Line 1, line 2. Where do they intersect? Well, they set up really nice for elimination. So let's write them down here. Line 1, line 2, and let's add them together. The y's eliminate. We have 2x equals 1, so x equals, when I divide by 2, 1/2. Okay? Then I'll use, if I know x equals 1/2, I know x plus y equals -1. I know x is 1/2. So if I subtract 1/2 from the left side and the right side, I end up with y equals -1 minus 1/2 is -3/2. And I'm almost done. I just need to write the solution, 1/2, -3/2. And I'm all done. Problem 5. A hotel offers single rooms for $90 a night. Those are for single rooms. We'll call those X. And they'll offer suites. Let's call those Y for $150 a night. One night, a clerk notes that there were 24 rooms were sold, but did not write down how many of each type were sold. The hotel charged a total of $2,520. How many of the rooms were sold? Suites. Show your work. Well, we know that there was a total of rooms of 24, so that's X plus Y. Suites and singles, there were 24 of them. We also know that the singles are $90 each, and the suites are $150 each, and the total amount was $2,520. So in this case, elimination makes the most sense. We're going to multiply the top equation times -90, and what you end up with is a fancy equation here. Negative, I'm going to write it down here on the bottom. You get -90x minus 90y equals 90 times 24 is $2,160. Now I've made a mistake here because I did not include the negative sign. So I've remedied that. I'm going to add the equations together. The 90x's are going to cancel out, and I end up with 150 minus 90 is 60y, and 2,520 minus 2,160 is going to be 360. So y has to equal 6. There were 6 suites. So a lot of times the questions on the test will ask you, what does y represent? We know that the y's are suites. So if there's a total of 24, then that means that x, the number of singles, has to equal what plus 6 equals 24? 18. So your final answer is 18, comma 6 as an ordered pair. And again, they represent 18 single rooms and 6 suites. 6. Solve the system of equations by any method. Be sure to identify the solution. Okay, this is set up as a in slope-intercept form. So the first line, the purple line, has been graphed for you already. It started at 2, because that's the trailing number. And the slope was 1, so it goes up 1, right 1. It also goes down and left, and you can see that graphed at the right. I'll graph the second line in blue. The second line is in blue, and it's got a trailing -1, so 0, -1. And its slope is rise 2, run 1, rise 2, run 1, rise 2, run 1. We can see that it intersects. Right there. This is line 2. The intersection is at 3, 5. So our solution is 3, 5. Problem 7. The system of two linear equations is shown below using intercepts. Okay, so using intercepts is pretty easy. You can make the x-coordinate 0. So in essence, if I put a 0 in here, I've eliminated that, and I see that y equals 8. If I do the other, making y 0, I get 2x equals 8, so x is 4. So it's very quick. It's a quick way to graph. I'm already in blue, so if I put a point at 0, 8, which is up here, and I put a point at 4, 0, that, if I graph that line, that's line 1. Now I'll do the same thing for the other. If I make x 0, I got -4 equals 12, so if I divide by -4, y has to be -3. And if I make y 0, x equals 12. So if I go, I have to extend my graph a little bit. 7, 8, 9, 10, 11, 12. 12, 0, and 0, -3 is here. And it looks like 5, -2 is the answer. Now I'll just check that real quick over here. If I put 5 in here, I'll put 5 for the x, -2 for the y. That will give me 10 plus -2 is 8. Check. And if I put a 5 in here, that's 5. -2, that's going to be 5 plus 8 equals 12. That's not correct. So we might have a mistake here. 5. Let's go back to our graph. We're in purple here. 0, -3. 5, -2. Maybe we made a math mistake here. X is 5. Y is -2. So another way to check it would be, well, my graph's not super accurate. Let's try it with elimination really fast. If I multiply this line 1 times 4, I get 8x plus 4y equals 8 times 4 is 32, but x minus 4y equals 12. If I add these together, I get 9x equals 44. So I'm seeing all of a sudden, wow, solving by graphing was not possible, because I get x equals 44 over 9. And that's okay, because then I could just I'll solve it for y. 2x plus y equals 8. 2 times 44 over 9 plus y equals 8. I need a little bit more space, so I'm going to erase this. Fully erasing to gain a little bit of space. I get 2 times 44, I'm working on this equation. 2 times 44 is 88 over 9 plus y equals 8. And if I subtract 88 over 9 minus 88 over 9, that would be y equals, we need to change 8 to 72 over 9 minus 88 over 9. Y is going to equal negative 16 over 9. So this is a pretty difficult location, making the equation true. So write it as an ordered pair and you have your solution. Problem 8. Marleigh and Craig are each riding on the same straight bicycle path. They both start riding at the same time in the same direction. Marleigh began riding at the start of the path, and Craig began from a spot 6 miles ahead. These equations below represent their distance along the path in kilometers y over time in hours x. So they've already set up line 1 and line 2. One of them is isolated, they're both isolated for y, so substitution would be really easy. Substitute the 12x into Craig's equation, and you get 12x equals 10x plus 6. Subtract 10x, and you get 2x equals 6. So x equals 3. We know that y equals 12x, so y equals 12 times 3, which is 36. So the solution was 3, 36. After how many hours do Marleigh and Craig meet on the path? So it would be 3 hours and 36 miles. A linear equation is graphed on the coordinate grid below. When graphed on the same coordinate grid, which equation results in a system of equations with exactly one solution? So this problem is asking us, some of these lines might be parallel. That would be no solution. If they're parallel lines. If they're the same line, it would be infinite solution. So we're looking for an intersecting line. Is one solution. So anything that has a different slope is going to intersect eventually. We could graph this quickly. We could use intercepts. Another method would be to manipulate the equations and look at their slopes. Let's take intercepts for a second. Okay, 0, 0. So if we make x 0, we get y as negative 1. When we make y 0, we get x is negative 2 over 3. If I graph that, 0, negative 2/3 is there. 0, negative 1 is there. I'm sorry, negative 1, 0. And it looks like we might have an intersecting line here. Let's try the next one. If I do change this one, let's look at what this equation actually is. It looks like it's got a slope of intercept at 0, negative 3, and it looks like it rises 3, left 2. So the slope is negative 3 over 2. So this line is y equals negative 3 over 2x minus 3. The only way we're going to be absolutely certain if we can find the line that doesn't intercept is to be more precise. So let's take each equation and rewrite it. Equation A, 3x plus 2y, 3x plus 2y equals negative 2. Okay, if I rearrange this, I get 2y equals negative 3x minus 2. If I divide everything by 2 or multiply everything by a half, I get y equals negative 3 over 2x minus 1. So the slope is the same. That cannot be an answer. This is no solution because it's parallel. Let's look at B. 6x plus 4y equals 8. 6x plus 4y equals 8. I'm going to move the 6x over. I get 4y equals negative 6x plus 8. If I divide that by 4, I get negative 6 over 4x plus 8 over 4. Again, negative 3 halves. The slope equals negative 6 over 4, which is negative 3 over 2. That's a no solution because they're parallel. So we're down to C. X plus 2y, this is line C, equals 2. So 2y equals negative x plus 2. And if I divide everything by 2, I get negative 1/2 x plus 1. I'm going to graph this in blue where m equals negative 1/2, b equals 1. This is definitely going to intersect and be the right solution. If I go to 1, I go down 1, right 2, down 1, right 2, up 1, left 2, up 1, left 2, up 1, left 2. I have an intersecting line. And my answer has to be C. I can stop there. I do not have to go on. And I get that problem right. Problem 10. The Johnson and Sloan families went to a Taco Mania for lunch. The Johnsons bought 3 burrito meals and 4 taco meals. So we'll call burritos X, tacos Y. They total $48. The Sloans bought 6 burrito meals and 2 taco meals for $60. So again, burritos were X, and the Sloans went 6X, change that to purple, 6X plus 2 taco meals, Y, equals $60. We have a system of equations. Let's multiply, if we want to eliminate, multiplying by 2 is easy, so let's multiply line 2 times negative 2. So the line 1.
Good morning, TJ teachers. Teachers, we would ask that you would please open your doors to your rooms at this time so that students can go in out of the rain. Once again, teachers, we ask you to stand by your classrooms and open your doors at this time. Thank you.
Negative 120, apologize for that. And we end up with negative 9x. The y's are eliminated, equals for 120 minus 48, that's 10, 11, 2, 72. So x equals negative 8. So if x is 8, we have 3 times 8 plus 4y equals 48. 24 plus 4y equals 48. And subtracting 24, 4y equals 24 and y equals 6. So $8 per meal for the burrito meals and $6 for the other meal. We're going to pause the video at this stage. Please go ahead to problems 11, 12, 13, and 14 on your own. Thanks.